Okay, so many of you are at new academies who have never been involved with the Cisco Academy before, and you're not aware of how the equipment works for Cisco Academies. Now, I will tell you, Cisco, and as part of this HBCU grant, is working on, for existing HBCUs and other HBCUs that come online, they're going to be providing some equipment, and it just depends. I don't have the details on that. I have zero details on it. But what I want to mention to you is what is typically associated with a lab. So when you go into my classroom, I showed you the other day on a Thursday, a walkthrough of my classroom, and I showed you the racks and the routers and switches. We purchased those routers and switches using the equipment list provided by Cisco. Now, this is the latest list that was actually released last Friday. This particular list has on it something completely new, and that is this C1000 switch. This Catalyst 1000 is a replacement for our 2960s. Our labs and all the labs that you're doing in Net Labs, our switches, as you will see if I go in here, I'll go in here and look at our switch. If I do a show ver, you'll see that our switches are 2960s, and you will continue to work in our Net Labs on 2960s. But any new purchases that we make at Stanley Community College, we will be purchasing these C1000s. The beauty of being a Cisco Networking Academy is this: you get, it's like a 50 to 60% off list discount for the devices that are listed in this particular Excel spreadsheet. Now, you can't just go and buy any piece of Cisco gear and use it in your your network for your college. That's not how it works. This gear can be used in your lab for you and for your students to work on the labs themselves. Okay. So the beauty though is you can see you can get two 4221s, two C1000s, and then just a generic router. Ebenezer, I'm going to mute you real quick. You were okay. Thank you. If you need me to unmute you, I can unmute you, Ebenezer. Let me know. But these devices you can order at a discount. Now, they don't come from us. They don't come directly from Cisco. The process is very simple. Inside of the Cisco Academy, there is an item under resources, all resources. And you will see it's under program resources. And program resources has an item called equipment information. This particular equipment information is where you can find out about how to order equipment. So equipment list by curriculum, this should have the new one. You'll see that that was just released last week. That's the one I was showing you. You will also see that there is an equipment ordering process. I can help you with this process. I have several vendors that are nationwide vendors that will honor the NetAcad promotional discount. If, however, your college already has a group they order Cisco equipment from, any Cisco reseller can sell you the Academy equipment at the Academy discount using this process. So if you already have a vendor you work with, they can do this for you. Okay. So you don't have to go find a new vendor. Now, I do have vendors if you need to find one and don't have one. I have vendors all around. And again, most of them are on your state contracts or will be on your state contracts. So just wanted you to be aware that that had just come out and that we did have a new set of devices, especially these C1000s, because a lot of people have been asking me what's going to replace the 2960s since the 2960s are end of life. So be aware of that. How many of you, by the way, on this call are going to be the lead contact at your academy, at your school?
I will.
Okay, Rashad, you will be? Okay, the reason I'm going to mention that is because one thing you will notice, if you are the lead at your academy, or if you have a special role called member of the support staff, you may have an I'm managing tab. If you're not a lead, you're only going to have I'm teaching and I'm learning. If you've got an I'm managing tab, that typically means you're either a main contact or you're a member of the support staff. And that's where you can get into here and make changes to the academy and do different things with the academy. Okay. So just be aware that main contact is extremely important. And if you have any questions, Rashad, especially with you as you're setting up your academy, I've got an entire document. I think I sent it to you on how to create your academy, request it, how to ask for ASC, all of those. The next thing will be when you get to the point you're wanting to buy equipment, just contact me and you and I'll sit down and we'll go over the process and discuss it and make sure you get the best possible deal you can get.
Okay.
All right. And that goes for everybody on the call. Anybody that's even if they're not a main contact, please let your main contact know that, or if someone's watching this later and was not able to attend today, we will be doing that. I cannot tell you how important it is to have real gear in your classroom. Now, you don't have to have the amount of gear we have. We have gear stacked on top of gear, but you need to have a couple real routers and real switches in your classroom so that your students can use them. That's why I'm so big on NetLabs. I know you're still not plugging the cables in technically on NetLabs, but I'm so big on NetLabs because it's real gear acting like, well, it acts like real gear because it's real gear. So just be aware of that. There are some optional products, by the way. They did add this, and this is something completely new, the Cisco 9200 Catalyst line. The problem with these switches, if you use this device, is you have to buy a license every 3 years. I am purchasing one of these for my class or for my academy so that I can look at it. As an academy support center, I have to really know a lot more about this equipment than you do. But I'm buying one to look at it to see how it's going to work because I'm really interested in just seeing how the DNA Essentials license is applied and how that will work as it calls home, or does it have to call home when you apply the license. I have not worked with the 9000 series at all. Has anybody on here worked with the 9000 series? Probably not. So it's pretty unusual. They just come out. They're fairly new. So they're a little hard to get a hold of at the moment, but I'm actually got a quote, trying to get a quote on one of these fairly soon. I will not tell you prices on equipment because that is dependent upon your area and your vendors. I can give you some ballpark figures, on pods, but I try not to quote anything because, again, I'm not the person selling you the equipment. It's going to be a Cisco reseller that does that. Any questions on equipment? You will see. Oh, go ahead. Go ahead, Jay.
Since you made mention of C1000 with 24 ports,
Mm-hmm.
and in the future it's not going to be available with the people that they already have the 2960 that is not from the Cisco that we just buy. We suppose that we have it from somebody else.
You're fine.
Will this one work with the, or how different is it going to be from the C1000?
What I have seen so far is very little difference in what we're doing with the devices between the C1000 and our current 2960s. The other thing to remember is this: if you already have 2960s, they are going end of sale, not end of life. They're going end of sale in October of this year, which means Cisco will no longer sell them. Cisco does not end of life any device until 5 years after the date of end of sale. So even though you can't buy them anymore after October, and honestly, it's almost impossible to buy 2960s now, new 2960s, because there's none in the channel at all. So pretty much you got to buy C1000s now. But if you have 2960s, they're going to be supported until 5 years from now, so 2026. So end of sale is in October. End of life is October 2026. So if you have 2960s, you're not out in the cold right now. And if you just bought 2960s, which I did, I just bought what, 8 of them, 8 or 10 of them not long ago. I had to because I had to put them into my NetLabs to add those new 4 pods. But we're good for the next 5 years in terms of support if we needed support on them. Okay. Does that help, Jacob? But there's very little difference in what we're doing, especially with the CCNA, because the commands we use are so simple. We're not really doing a whole lot of things in the commands that are wild.
So how is that one going to be compatible with a new Windows 11 now? Since we're talking about equipment now.
Windows 365, I have no idea. I have not even looked at it. My understanding is I don't know. I hadn't even looked at the Windows 365 and the Windows 11. And honestly, I don't think our campus is even considering that for some time. For really what we do on our labs, if you think about our labs, there's no reason we couldn't just stick a Linux box right here. There's no need to have a Windows box. All we need is something to put IP addresses on, because that's really all we're doing with these PCs is putting IP addresses on them and pinging from them. So we could really replace the PCs with a very simple Ubuntu box and put IP addresses on it and be able to do 99% of what we've been doing on our labs. So I don't really think, as far as PCs go, you've got to worry a great deal about that. Okay, any other questions? All right, I want to take just a couple minutes in to look at this module 2. And one of the things I do want to talk a little bit about is ingress and egress. And that is one thing to always think about is that when you're looking at a networking device, ingress and egress, you need to look as if you're sitting inside the device itself. So if it's an ingress, it's coming into the device. If it's an egress, it's exiting the device. But switches are, as we described in our class last Thursday, switches are multi-port bridges. They develop tables, content addressable memory tables, that learns the source and destination or the source addresses on each port, and then uses that to build this table so that you can send devices directly between ports easily and quickly. So it's a layer 2 device, typically, that does forwarding based upon layer 2 addresses, which are MAC addresses. Now, we have a couple different ways that we can do what is called our forwarding. One is called store and forward. With store and forward switching method, what happens is the entire frame has to come into the switch. You run a CRC against that frame, and then the frame is then sent on to its destination. So store and forward makes it impossible for a damaged frame to leave the switch. Okay. The problem is, because you think about it, how much time does it take to bring that entire frame in, do the error checking on it, then send it out? So store and forward has the least possibility of an error occurring, but it is also one of the slower methods. Having said that, because of ASICs, application specific integrated circuits, this is the method that is most commonly used in Cisco's switches, because it does ensure that no damaged frames are ever sent. There were 2 other methods. One was, well, there were 2 other methods, but they both were under what was called cut through. They were called fragment free. There's fragment free, which was one, and basically it starts sending it as soon as the destination MAC address is received, it starts sending it. And then there's another version, and that actually is the one that does it. Hold on one second. I got to do. Let me pull up my little diagram. Okay. Okay. Let me ask you this question. What is the smallest frame? Well, what is a 64K frame on an Ethernet link considered? Does anybody remember? So let me pull up Notepad. So let's say a frame, if you have a frame and it comes into a switch, then it's 64K. What's that going to be considered? Anybody know?
A runt frame.
The runt. Yeah, it's a runt. Okay. So a runt is actually a result typically of a collision. So this is what's called a runt frame. And it is an error frame. It is not a good frame. It's usually a result of a collision. Okay. Well, with our cut through methods, there are 2. There's one called fragment free and one called fast forward. But there are 2 cut through switching methods. All right. With fragment free, what happens is as soon as more than 64K is received successfully, it forwards the frame, starts forwarding the frame. Now, the idea is this: if it's at least 64K in size, it can't be a runt. So it's not going to be a damaged frame. That's the assumption. Now, that's assuming a lot, because unless you can have network runs that are too long, you can have other issues with it. So that's one. And then you've got the other cut through method, which is called fast forward, which forwards as soon as the entire destination MAC is received. Now, the thing about these two is this: it is still possible that you could have on either one of these, that you could end up with an error frame, even though they meet both of these requirements. But they are very fast. And on most modern networks, you could get away with either one of these and not have problems with forwarding frames that have been damaged. The good news is, though, because of our advances and application-specific integrated circuits, store and forward is our most common method, and this brings in the entire frame, runs CRC, then forwards. And most switches today have the horsepower to handle store and forward. So really, there should never be a frame forwarded out of the switch that's damaged. Now, it could still be damaged on its way to the device, from the switch to the device. So that's why the device runs its own CRC on it. But that is what's being talked about right here with our switch forwarding methods. So a frame comes in on the egress, and then depending upon which one of these forwarding methods is in use, is how the frame how the switch deals with that frame. It will either bring the entire frame in, run CRC, everything's okay, forward it. Or if it's doing fragment free, as soon as 64K plus of the frame comes in, it starts forwarding it and sends out the egress port. And then fast forward, it takes in the entire destination MAC, and then it starts sending it. All right. Questions about that? Now, that really is about all Module 2 is about. And then it gets a little bit into collision domains and about full duplex and half duplex, which we've already talked a great deal about last semester. You know, full duplex is when you have a send connected to a receive channel on the other end, and vice versa. Half duplex is where you can only send or receive. You cannot do both at the same time. And then a broadcast domain is just any area within which a broadcast would affect everyone. So typically on a single switch, that switch is an entire broadcast domain. And then also, if you connect multiple switches together, they're all a broadcast domain. This right here leads us directly to Module 3 in our discussion that we had of VLANs, and we're having of VLANs. With a VLAN, let's imagine that on this network right here, we don't want the PC on the right, this one right here, okay, the far right, to hear from these other three. What could we do? What is one method we could do? So let's actually pull up packet tracer.
Subnet it.
You could subnet it. First off, that's an excellent point, and that is that VLANs equals subnets. So every VLAN is its own subnet. So let's pull this up right here, and then let's pull this out over here. And I'm just using packet tracer because it's fast, folks. That's the only reason. So let's do this. So let's take out here, and we're going to do an example. So there's a switch. We're going to grab our PCs. There's our server. There's our PC. All right, so here's all our PCs. But we don't want this PC on the right, PC3, to be able to hear any of the traffic from these other machines. So the first thing we're going to do is take a straight through, copper straight through. We're going to connect all these to the switch. Now, why is that, Amber? Does anybody remember what I talked about last week?
It takes some time before the link.
Okay, and why is that?
STP.
STP, spanning tree. Yep, spanning tree. It's running through blocking, listening, learning, or whatever variant of spanning tree it's using. So what we could do here, if we want to ensure that PC3 cannot see any of the traffic from the other 4 machines on the switch, is we can take and create a virtual LAN. So now we're over here in this VLANs. What a VLAN is, one of the benefits is, we're going to break our physical switches up into logical VLANs. So let's go to the switch. And we're going to go in here. First thing we're going to do is we're just going to give it a name, host S1. And I've actually got to go into global config. And then we're going to do host S1. And now we're going to do a VLAN 10. And we're going to name it faculty. We're going to do a VLAN 20. And name it students. Type exit. Type Control Z. I'm going to do a show VLAN. You'll notice now that we've got VLAN 1 that has all the ports in it by default. And then we've got these two new VLANs with no ports in them because all we've done at this point is created the VLANs. So our next step is to put the ports into the VLAN. So ports 1 through 4, or excuse me, 1, 2, and 3. Actually, it'd be 4. 1, 2, 3. Ports 1, 2, 3, and 4 need to be in VLAN 10. So watch what I do here. I do config T. I do interface. Don't ever forget this command. Range FA0, 1 to 4. Switch port mode access. Remember, we're making an access port because we only want to support one VLAN. That's what access port means. It supports one VLAN. Then we're going to do a switch port access VLAN, and we'll put this in 10. Then we'll do interface FA05. We're going to do switch port mode access. Actually, we hit up arrow a couple times. And we hit up arrow a couple times and put this in VLAN 20. Then I'm going to check it. Do show VLAN. But notice now that these 4 ports are in VLAN 10, and this is in VLAN 20. So now I'm going to go over here, and you'll notice they all go back through spanning tree. So I'm going to take this PC and give it an IP address. 92.168.12.10. And I'm going to go to this PC, PC2, and give it 12.11. /24. Then we'll go to PC3 and give PC3 12.13. Okay. So now let's go see on this PC. Let's get the command prompt, IP config. I can type. So I'm going to ping 192.168.12.10, which is that first PC. Works perfectly fine, no problem. So I'm able to ping from PC2 to PC0. Watch what happens when I try to ping 13. Well, it wasn't 13, it was 12, wasn't it? This one has an IP address of 12. No, it's 13, okay. But watch what happens when I try to ping 13. It will not work. Why will it not work? Look right here, folks. You'll see port 05, where PC3 is in VLAN 20. These others are in VLAN 10. So what happens is this. This is a very important part. I'm actually going to pull, I'm going to do a little bit of, it's going to take me a second to get this pulled out, but I want to do this for you because I want you to see this. I'm going to create a new whiteboard. I'm going to go here, and I'm going to get me a new image. All right, so when PC2 tries to ping PC3, here's what happens. So let's assume we're going to make VLAN 10 red. Okay. VLAN 20 we'll say is blue. And that's because of the tags. So what happens is literally out here on this link, nothing is tagged. PC2 tries to send the ICMP echo request. It comes up this link, up to the switch, to this ingress port. As soon as it comes in this port, it is tagged as a red frame. because it is part of VLAN 10, which means it could go to this port, it could go to this port here, or it could go to this port here. It cannot go to this port because it is tagged with the 8021Q tag for VLAN 10. And the switch will only send it to other ports that are in that VLAN. Now, if PC2 was pinging PC0, what would happen is it would come in, it's untagged out here. By the way, if you ever wondered why we put in the command switch port mode access, that command tells this link that nothing on this link should be tagged. So if PC2 pings PC0, it comes in untagged, it gets tagged inside of the switch, and then the second it leaves this switch going back out, it is untagged again. The 8021Q tag is taken off. And the reason is because if you leave the tag in, the frame becomes too big. It's a jumbo frame, and the PC thinks it's damaged and will throw it away. So this command right here is what allows us to have these untagged frames. Now, here's an interesting thing. If I put a switch, another switch over here, this takes us into our next discussion that we're going to have, and another PC over here. And let's imagine that this PC wants to be part of VLAN 10. Okay. We've got to have a way to maintain those tags between the switches. So what we do is we create a trunk link. I do it with all the colors because the trunk link can carry all the tags. That command is switch port mode trunk. Okay. If you put that on both sides, so this port and the port down here, then tags can be maintained across it. Questions about this diagram I'm showing you? Any questions at all about this?
What if you have a writer between the PC3 and the switch?
Okay, totally different then. If you put a router in here, then the router is going to break it into different networks. Okay, so if you put a router in here, then you cannot maintain layer 2 tags across that router. Okay, now we'll take for the let me tell you this. For the purposes of the CCNA class, you cannot maintain tags through the router. There are ways to do some really weird encapsulation that you're still going to lose your tags. You're still going to lose your tags across it. So if you put a router in there, you lose your layer 2 tags. So a router in here changes everything. That makes it 2 separate networks. Okay. We're going to talk about inter-VLAN routing in a minute, but let's show this. So let's imagine we've got this design here, but we want to put another switch in here. Okay, we put another floor in the building, and we want to connect these 2 switches. Typically use a crossover cable between these. So we're going to do gig 00, 01 to 01, gig 01 to 01. All right. And we're going to put another PC over here, and this PC needs to be in VLAN 10. So what we're going to do is this. I'll show you how simple it is to actually configure this. So we go to this switch right here. Config T hostname S2. We're going to do VLAN 10. You got to create the VLANs locally. Name faculty. VLAN 20. Name students. Unless you're using BTP, which we are not. And then we're going to go interface FA01 switch port mode access, switch port access VLAN 10. All right, and then we're going to go into interface G01 switch port mode trunk. All right, go to switch 0. Go to GI 0/1 switch port mode trunk. And we should here shortly end up with a trunk. Do show int trunk. Between these two, you'll see gig 01 is trunking. All right. Now it's got to run through spanning tree. Still got to run through spanning tree. And while it's doing that, I'm going to go to this PC and put an IP address on it. So we're going to give it, we'll do 192.168.12.50. So we know it's way out there on its own. So we're still waiting for this to come up. Give it a second here. There. All right. So we got a trunk link working. Now watch this. I can go in here and I can do a ping 192.168.12.10. And the ping is going all the way across. And in fact, if I change the simulation mode and I do this ping, watch what we can actually watch happen. You can actually watch this go across. So here's a ping. It goes in from the PC to the switch. It goes across here. And in fact, you can even, if you dig down into this particular switch, you can actually see the .1Q header. See that? How the .1Q header has in it the information about the VLAN it's part of. And you'll see it come across, go out the PC 0, and then come back. And watch this. I'll show you something cool. Let's actually watch it come back. Let's watch the second one. Somebody, that was a broadcast there, but let's watch the second one come over. All right, now let's look at that one right there. You'll notice there's no .1Q information because this is the frame out here on this access port. So the .1Q information is removed when it leaves the switch. When it comes back in the switch, all right, and starts its way back across here. Notice how the .1Q information is now back on that packet or that frame.
Why is that one happen?
Because it's moving across the trunk link. Anytime it's inside the switch or going across a trunk link, the tag is maintained. If it's not, the frame wouldn't know, the switch wouldn't know where to send the frame. It wouldn't know what VLAN it was part of. So we're telling it to be part of a group 10, right? So we told it be part of group 10. Well, if it's going to be part of group 10, these switches have to keep up with it somehow. They do that with the 802.1Q tag. And it's only maintained inside the switches and across trunk links. It cannot be on the access links. The PCs honestly have no idea they're even in a VLAN. It's why it's called a virtual LAN. They don't know it. They just think they're connected to a LAN. They don't know they're connected to a switch that has 3 or 4 different virtual LANs on it.
Is there any other use for trunking besides maintaining the .1Q tags?
No, no other use for trunking other than .1Q tags. Now, one of the things you will find in the real world that we're doing now is, for instance, this server right here. We actually, let's say this is a VMware ESXi server. We actually trunk to our servers, and then virtual machines on that server can then be on different VLANs. So that's one thing that's a little weird you see out in the real world. You'll see a trunk link going to a server so that you can maintain virtual machines and put them on different VLANs. But that is the only use for a trunk. So questions about that? So as we look at VLANs, okay, and some of the benefits, again, we talked about smaller broadcast domains, improved security, because we're keeping those students off of our network, the faculty network, better performance, reduced costs, because we don't have to buy, you know, other options to buy a switch for the students and a switch for the faculty. Well, that's crazy. Okay. You'll notice here that we do have different types of VLANs. We have our data VLANs or default. Well, first we have default VLANs, which is VLAN 1, which is on every single switch. We also have normally these default VLANs that are in there from legacy support for FDI or Fiber Distributed Data Interface and Token Ring. And then we have our data VLANs, and those are VLANs that we create ourselves to put user traffic on. We're going to talk about native VLAN when we get a little more into trunks here, but the native VLAN is just a legacy support mechanism. That's all it is. It's kind of weird. Our management VLAN, which we used to use as VLAN 1 by default, but you'll notice all of our labs now have us using a different VLAN than 1 for our management. And that is because it's a massive security hole to use VLAN 1 as your management VLAN, because all your ports are part of VLAN 1 by default. And then you have voice. This is that weird little thing I talked about with voice, how we've now set it up to where with switches, you actually using CDP, Cisco Discovery Protocol, and LLDP now, Logical Link Discovery Protocol. You can connect to your IP phones, and the phone will have what's called a voice VLAN, and it will have a data VLAN, so that you can connect your PC to the phone. And basically the phone is acting like a little switch here. The phone has a built-in switch. It's really what it comes down to. And so it builds a mini trunk right here between the phone and the switch, so they can carry both voice and VLAN, voice and data traffic. There's 2 VLANs on it. That's what is meant by a voice VLAN. Okay. But now, second we get multiple VLANs and we get multiple switches, our problem becomes that we've got to carry the tag across this link, and that's where we trunk. So we could do it with no VLANs, which would be an absolute disaster because everybody would see these broadcasts. But if you get a VLAN, you make VLANs, and notice how the broadcast will only go to the VLAN that is associated with. And that is because the switch maintains the trunk. So you'll see here, when this comes in to switch 2, it will see that it come in on a port that's been associated with VLAN 10. So it tags it as part of VLAN 10. That broadcast comes across this trunk tagged as part of 10. S1, if it had any ports in VLAN 10, would have sent it out those ports. It will then send it across this trunk, and then this switch will look at all the ports it has that are in VLAN 10 and will forward it out that port after removing the tag. And that's all this is right here, is a little tag that gets placed after the source MAC right before the type length header. And it's used to hold the VLAN ID. And this is why you have 4096 VLANs, because you got 12 bits in here. All right. So 8021Q is our tagging method we use. If you do a lot of reading, you may learn about interswitch link or ISL. That was another method. We don't use it anymore because it was Cisco proprietary. So here we look at old school, way back in the day. You would have to say that even if it was a trunk link, you could not say there wouldn't be a hub on it and a PC on it. This is the only reason we have to have a native VLAN on a trunk link. And I'm going to teach it to you the easiest way I know how to tell you is this. The native VLAN has to be the same on both sides of a trunk. By default, it is VLAN 1 when you do switch port mode trunk. In fact, if I go in here and look at these right here, you'll notice that when I did just switch port mode trunk on both sides, you'll notice that it says that this trunk, this port gig 01 is trunking with 8021 encapsulation, and the native VLAN is 1. The native VLAN has to match on both sides. So by default, it is 1 if I change it on this side. So if I do switch port, trunk, native, and say I put 200, which is actually a good thing to put it on a non-existent VLAN. But if I do this, I got to put VLAN, native VLAN, 200. If I do this, watch what starts happening. I'm going to start getting error messages telling me that there's a native VLAN mismatch. I'm going to get it over here, actually. As soon as that comes back up and it starts figuring it out, it's going to say there's a native VLAN mismatch. So do show int trunk. You'll notice that this says native VLAN 1, whereas this is on VLAN 200. Real world, we would have already started getting all kinds of messages saying mismatch native VLAN, mismatch native VLAN, mismatch native VLAN. So if you change it on one side, there it goes. See, native VLAN mismatch, 200 on this side, 1 on the other side. So what you just do here is do switch port trunk, native VLAN, native VLAN 200, and that fixes the problem. The only reason we still have this command around is to support this crazy legacy concept that you might could have a hub out here on your trunks. You should never have a hub on your trunks. Okay. So all the native VLAN says is that traffic on that trunk does not get tagged. It must be untagged. Okay. Let's see, VLAN configuration, super easy. I've already showed it to you. You just do VLAN number, give it a name. Okay. Then you assign ports to it. Access means it can only be part of one VLAN, and that is the VLAN that you associate that port with. In this case, port 06 is part of VLAN 20 on this particular switch. Here's an example if you're supporting voice VLANs. Here's how you can actually set up voice VLAN on a switch. Switch port mode access, but then you say switch port access VLAN 20. Then you put switch port voice VLAN 150. If it supports it, it will then go through and do the negotiation with the switch, and we'll use this for the voice traffic and this for the data traffic. So it knows this is data and this is voice. This is a specialized set of commands that works only on Cisco devices. Other devices have their own set of commands that do the same thing, but they may not use the exact same commands. But this just allows you to support both voice and data on that one. If you want to verify your VLAN, do show VLAN summary, show VLAN period to show VLAN. If you want to see port membership, you usually do show VLAN and just look at the port membership. If you want to take a port out of a particular VLAN, you can do no switch port access VLAN, and it will automatically move it back to VLAN 1. So a port must always be in a VLAN. If you take it out of VLAN 1, put it in 10, and then take it out of 10, it's going back to 1. So one of the things they have you do in our labs, they have you park your ports in an unused VLAN. It's called a black hole VLAN. So a lot of times we create a VLAN that we park our ports in so they're not stuck in VLAN 1, because every single port by default is in VLAN 1. The other thing is this: when you create VLANs, they're not stored in the running config file. In fact, if you look here, you'll see if I do a show run, nowhere in here do you see the commands I use to create the VLANs. You see the VLAN membership, but you see nothing that shows the VLANs themselves. This file right here, this VLAN.dat, is what holds your VLAN information. So if you want to get rid of your VLANs completely and reset a switch, you actually have to do this. You have to actually do a del /: VLAN.dat. Delete that file, and then you got to do an erase the startup config, and then you do a reload. And if you do that, that will get rid of all the VLANs. And then let me ask you this: what port then would all the, or what VLAN would all the ports be in once I reboot this switch? Anybody tell me that?
What was the question again?
The question was, once I reboot that switch, I've deleted the VLAN.dat, I deleted the startup config, and I reload the switch. What VLAN will all the ports be in by default?
Your default VLAN?
Which is?
VLAN 1.
Correct, VLAN 1.
Okay.
Yep, that is correct. So by default, all ports are in VLAN 1. So here I'm going to do the same thing here, and I'm going to reload switch 2. And you'll notice as soon as switch 1 is reloaded, I go in here now and do a show VLAN. All ports are in VLAN 1 by default. And then here's our other default VLANs that are on the switch. Very good. Questions? All right, we talked a little bit about trunking. Talked about the fact that when you create a trunk, it maintains the tags across that trunk. That's the only purpose of the trunk, is to maintain the tags. So here we've got these 3 VLANs, and we want that information to be maintained across switch 1. Okay, so we do switch port mode trunk. We do not, these 2 right here are optional commands. They are not required. By default, the native VLAN is 1. And by default, all VLAN traffic is allowed. So this command here would change your native VLAN on both sides. So that would be your untagged VLAN for the trunk. This says what VLAN traffic can go across the trunk. You have to be careful with this, because if you do this and add another VLAN, and you've got 30 switches and 30 different trunks, you have to go and touch every single trunk link to add that VLAN in as an allowed trunk. If you're not running some kind of wild thing like DNA Center or some other campus-wide management system from Cisco. So allowing this is it's your security best practice, but you really want to only do this after you've created all the VLANs that you're going to have, and you're not looking to add very many more. If you want to verify trunk configuration, you can do it this way: show interface F01 switch port, which would be the port that is trunking, and it would tell you, or my favorite is just show interface trunk. That's the easiest way to do it. And if you ever want to change it back to being non-trunk, just do no switchport trunk allowed VLAN, no switchport trunk native VLAN, or just type in switchport mode access. That'll get rid of the trunking on it. And it'll be back to its defaults. Okay, any questions? So let's go over here now. All right, so let's look at this lab on S1 and S2. If I wanted to configure a trunk between FA01 and FA01, what command would I have to do on S1? I'm going to config T. I'm going to host name S1. So I want to make FA01 into a trunk. So what's the first thing I got to do? Y'all got to walk me through. I'm a new, you just hired me as a network admin and sent me out to work on a network. So what am I going to do? Here's my topology. We've got to make FA01 and 01 a trunk. Anybody? First, let's go to FA01. With me there. What command turns it into a trunk? Hello, wake up. Everybody live?
Oh, we see here.
Switch port mode trunk.
There you go. That's all you gotta do. Switch mode trunk. So now let's go over to host 2 or to switch 2. Host S2 and FA0/1 switch port mode trunk. Now watch this. Once we do this, we're going to have a trunk. Do show int trunk. You'll see here we've got a trunk. FA01 is a trunk, and native VLAN is 1. You'll notice that all VLANs are allowed on this trunk now, because that's the default configuration, that all VLANs are allowed. We could also do this. We could do a do show interface interface. Oh, that's right. FA0/1 switch port. And you'll see that it's telling you that it is trunking. So it's .1Q trunking. It also tells you what VLANs are enabled. Trunking VLANs enabled all. All right. So let's change our default native VLAN. So let's do switch port trunk native VLAN. And let's change it to 200 again. And let's do switch port trunk allowed VLAN. We're only going to allow 10, 20. We're going to allow 1, 10, 20, and 30. Okay. Can't use plural on that. So now let's go back over here and do the same. Let's do switch port trunk native VLAN 200. By the way, you know I'm just tabbing these out. That's all I'm doing is tabbing out 1, 10, 20, 30. All right. Do show int trunk, and that's just because I'm not going to bounce out of the config mode. I'm too lazy to bounce back and forth. So now you can see that on this port, we're still trunking. We've got a native VLAN of 200 now, and we're only allowing VLANs 1, 10, 20, and 30. Now, what if I need to add VLAN 40? So watch this. I'm going to say, okay, I need to add VLAN 40 now. So let's go and allow VLAN 40. Okay. Watch what happens. Uh-oh. The allowed VLAN command overwrites the other command. So I thought I was just adding it so it would support 40. No, when I did switch port mode trunk allowed 40, VLAN 40, it actually said the only VLAN it's going to allow is 40. So I would actually have to go in here and do 1, 10, 20. This is where people in the real world get into big trouble. 10, 20, 30, and 40. And then I'd have to go back on this other side over here and do the same thing. I'd have to do 40. And this command is actually overriding the other. And now I'm allowing VLANs 110, 20, 30, 40. There you go. Then of course I'd have to create my VLANs now. So VLAN 10, name, and I'm not following the lab, folks. I'm doing this on my own. Now watch this. Remember, if I do a do show VLAN, I'm only going to see 10, 20, and 30 because that last VLAN will not go into effect until I exit from config VLAN mode. When I exit from config VLAN mode, then it gets written to the VLAN.dat file. Okay, so all those are there. And over here, same thing. VLAN 10, name faculty. 20, 30. And now let's go and look at what the PC is on. The PC is on port 018 over here. So let's go exit int FA018. What command makes this an access trunk for only one VLAN? Switch port mode access. And then switch port access, we're going to make this part of VLAN 20 because this is a student PC. VLAN 20. No shut. Actually, I'm going to do this till I'm going to do spanning tree port fast because we know this is a command port fast. Okay. And this is 06, I believe, over here. Yep. So switch port mode access. Switch port access VLAN 20 spanning tree port pass. Okay, now you'll notice if I do a do show VLAN, you'll notice now that this port 06 is in VLAN 20. If I go over here on S2 to a do show VLAN, you'll see port 018 is in VLAN 20. If I put IP addresses on PCA and PCB, they should be able to ping each other. In fact, they probably will already be able to ping each other because they will have an IP address on themselves. Because if I do an IP config, they're going to have a PIP address, right? So it's a 169.254 number. So watch this. We'll do this, make these actual size. And we can actually ping between these two PCs using their PIP number. Let's undock. I don't know who somebody just blew the clown horn at me. Okay, so let's do an IP config. So this is 169.254 43.108. 43.108 is this one. So brain poot. 43.108. Ping 43.108. And look at that, ping works just perfectly. So we've set up.
Only because they're within the same network, right?
Correct, exactly. They're in the same network, so they're able to ping one another. So they're on the same network, this 169.254 network. They're able to ping each other. But the other thing is this, they're on the same network. They're also in the same virtual local area network, so they're able to see each other. Okay. If I go over here to PC to switch 2, and let's do this. Config, all right, so I'm in the same one. So let's do switch port, access, VLAN 10. Now this port 018 is in VLAN 10. And over here, this is in VLAN 20. PCA will not be able to ping PCB now. Because when it comes into the switch, it's tagged as being part of VLAN 10 that cannot get over to PCB without a router. You have to have a router, and we don't have one set up in this diagram. Looking at our topology, there's no router here, so there's no way to get between the VLANs. Second I fix that problem, second I go back over here, put it back in VLAN 20. You'll notice ping works. So here's the question, and here's where we're going to be going in our class meeting on Thursday. How do I route between VLANs? Well, that's the entire purpose of our next module, folks. Inter-VLAN routing and how we do inter-VLAN routing. So we'll hit that and start working on that and on STP concepts. Any questions for me?
I'm just going to have to run through it another time and listen to the video again.
Okay, that's fine. It's a lot to go through. It really is. I will say this, so VLANs, setting them up are really simple. You just create the VLAN, okay? You create the VLAN, give it a name, and you assign that VLAN to a host or to a port. So a port goes into VLAN, boom, you're good to go. I'll show you a trick here. Let's imagine I wanted to do a black hole VLAN, so I could create another VLAN. So let's do a VLAN 1000. I would do 100. Name black hole. So we want it to put all, so every port that's not already in one. So we'll do 02 to 05 and then 07. So switch port, let's see, exit, got exit. Interface range FA0/2 to 5, and I think I can do it like this, FA07 24. See if it'll take that. Yep, sure did. And I can do a switch port mode access, switch port access, VLAN 100. And actually I'm gonna do the shutdown command on them. Now if I do show VLAN, you'll notice that I moved everything but the gig ports. They're all being shut down now as they're going through the process. Hold on just a second, we'll show it to you. You'll see that all the ports except for the 06, which is in use, okay, and the gig, which I need to move over, have been moved into this black hole. And not only that, if I do a show, let's go ahead and do this too, int range GI01 to support mode access. This is the best security practice, by the way. We moved them out to a unused black hole VLAN, and then we've also shut down any unused interface. This switch, that along with things we'll learn later called port security, is about as secure as you can get it. All right. Well, folks, that's all I've got. I'm going to stop my sharing. Any questions for me before we call it a day? There's a lot of material we went over. So I suggest rewatching the video if you can. May not hurt to rewatch the video from Thursday of last week because there's some overlap between it. And otherwise, keep working on your labs, and we will meet back together next week, or not next week. We'll meet back together Thursday and go over how to do inter-VLAN routing. Okay.
Thanks, Kelly. Appreciate your time.
Thank you.
You're welcome. Let me